So like Troy said, what I'm going to do is talk about some new products that we've introduced in the last, I guess, 6, 7, 8 months. We'll talk about first the X9 scanner. Then we'll talk about the R580 GNSS receiver. And last, we're going to throw in there the TDC6 and the Mobile Mapper 6. So same product, different name, just under a different, one's under Trimble, one's under Spectra. So, but again, it's basically the same product. So first thing we're going to talk about is the X9. And X9 was put out June of last year in 23, and it is the next evolution of the X7 scanner. So I can't remember when it was that I talked about the X7. That was maybe back in maybe at the users group in 2020. I'm guessing that I maybe talked about the X7 because I think it was released in 2019. But yeah, so the X9 was built on the same platform as the X7, but that platform is about as far as it's going to go. Okay, everything pretty much the guts inside is all basically brand new. Okay, so it is a high-speed scanner that has great range and accuracy. It's run by Perspective. We'll talk about that a little bit more on a future slide. But for a lot of you out there, right, you're maybe more familiar with Trimble Acess, which runs our total stations, our GNSS receivers. Perspective is the software that runs our scanners. Okay, it's got a range out to 180 meters. Really good range noise. We'll talk about some improvements that we've got there as far as how the X9 has improved. Just made some improvements again from the X7. Again, that's kind of going back to the new guts in there that I talked about. We can collect up to a million points a second. Okay, as far as that goes. Scan durations, right, from just a little bit under a minute to just a little bit over 6 minutes, depending on what type of settings that we're going to do. It's got a great IP rating. And one of the things that we did kind of disrupted the market when we released the X7 was we put it out with a 2-year warranty. The X9 continues that tradition, again, with a 2-year warranty. And what we did was kind of make some other manufacturers catch up with us, right? So that was that was a good thing, right? And that's good for the end user, right? Having a 2-year warranty. So a couple other things that are not on this slide that I want to talk about is just the X9 continues along with the auto calibration that the X7 introduced. So basically what that does is we are checking the calibration of the unit prior to every scan that you do. And as long as that calibration comes back okay, your scanner is good to go. It doesn't need to go in for annual service. So that can be a big cost savings and a big production savings for you that would have either an X7 or an X9 scanner. The other thing it does that we don't talk about on this slide is it's going to self-level, right? So as long as we're within 10 degrees of level, the X9 is going to level to less than 3 arc seconds, right? So again, for certain applications in the scanning world, that's going to be quite important. So this slide just talks about some of the scan times that we've got and some of the different modes, okay? So the top 2 modes that you've got, the indoor mode and the standard mode, when we are in those modes, we are collecting at 500,000 points a second, okay? You can see the maximum range that we've got there, so 30 meters on the indoor mode. The other thing we do on the indoor mode is we kind of optimize the calibration, right? So by optimizing that calibration, when we're indoors, right, typically we're working in a little bit more of a controlled environment. So it is not as important for us to do all of the fine detailed checks on that calibration when we're working inside. So, and again, we're also limited in range there, right, to 30 meters. Now, the standard mode, again, will take us out to 150 meters. You can see you've got some different options there as far as scan duration, okay? And again, we're going to be collecting at 500,000 points on those. So the high-speed mode will get us out to 120 meters, okay? And when we're in high speed, we are collecting at 1,000,000 points a second. And again, you can just see the duration of those scans. You know, we give you some point spacing, things like that in there. So, you know, just some different modes there with the scanner. You know, as far as talking about the X9, comparing it to the X7, it is a completely different laser source in the X9. So one of the reasons that we can go from, you know, the 80 meters that the X7 was at to 150 meters with the X9. And again, by optimizing, changing some of those procedures inside, we've also increased the angular accuracy. Oops, sorry about that. We've also increased the angular accuracy, dropped it from 21 seconds with the X7 down to 16 with the X9. Again, we've already talked about the 1,000,000 points per second compared to 500,000. Range noise is a big thing that we've done as well, right? So you can see we've trimmed 1 millimeter off of the range noise out at 30 meters. So that's, again, a good improvement. I'll have a slide here where we'll talk about that. One of the things that the X7 introduced for us was, you know, if you are a scanning professional, some of the things that are notoriously hard to collect out in the field are going to be really shiny objects or black, really dark objects. Okay, it is just kind of the nemesis of modern scanners. The X7, when we introduced it, had a high sensitivity mode. And what that high sensitivity mode would do was increase the power to the EDM, and it would slow down the horizontal rotation of that instrument just slightly. And by doing that, we were able, with the X7 laser source, to pick up black objects better than just about any other scanner out there. We've got one guy on our testing team that is incredibly critical. He's was in the market in Vegas prior to coming to Trimble. I don't know what that was, maybe 10, 12 years ago. And he is one of the most critical testers that I've ever seen. And so when he tells me things, I believe them. And he is one of the first people to tell me that the X7 picked up, you know, shiny and black objects better than anything he's ever seen. So again, I hold that in very high regard. With the X9 and with the new laser source that it has, one of the great things we don't have to do is we don't have to put it in this high sensitivity mode. Okay, we collect shiny and dark objects better with the X9 than we actually did with the X7. So again, that's just a great improvement. You know, the other couple things in here, just talking about the image processing and that optimized calibration routine in certain settings. Okay. So here I'm just going to continue talking about some more improvements with the X9. So on the left side, you can see the same scan from the exact same location. Left side is X7, right side is X9. Okay, you can kind of see the picture down below. Hopefully you can see my cursor in there a little bit, but you know, you can just see, for instance, this dark building, right? We did not get it very well with the X7. Again, the X9 just picks up dark objects very well. If we look at this building here, okay, on the right side, the tall building on the right side, you can see you've got a lot more detail coming off of the roof with antennas, chimneys, vent pipes, things like that, than we do with the X7. And then if we go further back into some other areas, you know, over here on the far right-hand side, for instance, we were just out of range with the X7. So things that the X9 can pick up opens doors for you from a project perspective, right? And can be a big production time and efficiency savings for you, not having to do quite as many scans and quite as many setups. So again, this is just kind of diving into that picture again a little bit more. And if I look at the point, okay, on the X9, on the right side, what we've done is we've called out specific points. So the point to the furthest right, that is out at about 75 meters, okay? So you can see, again, looking over at the X7, just we're not quite as dense as what we picked up on that building. When we go down to actually the lowest point, moving from left to right, okay, That point is at just shy of 149 meters. Okay, so you know, again, when we say this, the scanner can get out to 150 meters. That point right there is kind of proof positive of that, right? We're just a meter shy. Now, when we go to that building that's got a lot of detail on it, the highest point there, you know, that's just shy of 50 meters right there. And, you know, again, you can just see the detail that we picked up. And then the point to the furthest right, that's just the peak of a building. And that was just shy of 101 meters. Okay. So again, we are getting quite a bit of detail, you know, with the range improvements that we're seeing with the X9. One of the other things that we talked about was the range noise improvements, going from you know, less than 2.5 mils with the X7 to less than 1.5 mils with the X9. Okay, so I hope that everybody can see this on the slide, but on the detail on the right hand side, you're going to see a solid line. That line should be green. Okay, and that line represents a wall. And then we're going to have two different set of points, right? One that's blue and one that's red. The blue is going to be the X7, and you can see the spread of those points is bigger, okay, along that wall. So that is the range noise that we're talking about. Scanning professional may call that the fluff that you would see on a wall, okay? And the red points, the red clusters of points that we see in there, okay, those are going to be the X9. So you're just going to see that they are a little bit more tightly clustered around the actual position of the wall, right? So we did do some image improvements in there as well, right? So again, looking at this top image on the left side is going to be the X7. On the right side is going to be the X9. It is the exact same setup. So all they did was swap out one sensor for the other. And again, in the highlighted areas, you can just kind of see how that image processing is going to be better. And what that's going to lead to is better point colorization of your point clouds. Okay. In the bottom, we're just showing how we've made improvements moving from phase 1 to phase 2 and doing the alignments in there. Okay. So this scene right here, I didn't do this, but I'm assuming this is going to be a brewery. Okay. And if I was a scanning professional, I went in here, this would kind of be my nightmare scenario, right? With that highly polished stainless steel tanks that you know, they wanted to pick up. Plus you've got dark piping, you know, that's running, looks like electrical up along the ceilings. So again, just kind of a nightmare scenario, right? And when we go and we look, so this is a picture, okay? This is actually a point cloud. And the red areas that we see, okay, along those tanks and on the windows, those are areas that we did not get any data. Okay, so you can see that we got a lot more data in you know, a high percentage of the areas compared to where we didn't get data, right? And again, just looking back at that picture, right, and the polish on that stainless steel on those tanks, right? It's just not a ideal setting for scanners, but the X9 really did a great job. Really did a great job. And again, we don't have to put the X9 in a special mode in order to be able to collect that. So we can't really talk about the X7 or the X9 without perspective. I talked about this a little bit earlier. So just at a very high level, right? Perspective controls the scanner, right? Lets us decide how many, what duration of scan we want to do, images, whether we want to collect 10 or 30. It allows for in-field registration, right? So I am a scanning dummy, right? My background comes from surveying, right? I surveyed in the mountains of Colorado for about 9 or 10 years before I came to work at Trimble. So being a surveyor and talking about scanning is a little bit of an oxymoron for me because, you know, with scanning, if you don't do things like overlap, you've basically failed your project for the most part. And, you know, in surveying, those are things that we don't necessarily talk about, right? We're trying to pick up right where we left off. So perspective gives somebody like myself, who I would call, again, a scanning dummy, the confidence to take out this sensor and use it out in the field and leave the job site knowing that I've done what I need to do to be successful out there. Okay. This in-field registration is a big part of that. It also allows us to geo-reference out in the field. Okay. We can do some measurements. We can do annotations. Annotations, everybody always describes as sticky notes. So when you are out in the field and you are collecting data, a lot of the times it's easier to call out, for instance, if you're doing an industrial site or you know, an oil and gas substation or pump station or something like that. It may be easier to call out what these valves are, what these flanges are when you're in the field, as opposed to collecting the data, not annotating anything out in the field and letting the office guys do that. So it just allows us to do some production work while we are actually out there collecting the data. Okay. Kind of going along with the georeferencing, this precise point. So another thing that makes this scanner unique is it does have a laser pointer that can actually collect a precise point. So if we would have targets up that we wanted to use for georeferencing, we could actually go out, measure those targets, and use that in the field in perspective to go ahead and get our project georeferenced, right? And then of course we can do exporting, right? We can do you know, industry standard exports as well as Trimble proprietary exports in there. Okay. So here's what our scanning portfolio looks like today with the release of the X9. If we go right to left here, there's the X7. You can see the similarity in the form factor going to the X9. Okay. Next we have the X12. Okay. So that is our highest end scanner that we have, over 2 million points a second at its highest collection rate. It's going to have a little bit better range than the X9, and the accuracy is going to be better as well. Okay. Now further to the left, that is the SX12. Okay. So, you know, the SX12, I know it was in Emily's video at the beginning, but it really is a revolutionary instrument, right? It's a 1-second robot that can collect high-speed scan data at over 26,000 points a second. So there's really nothing else out in the market that compares to that today. So let's go ahead. We'll move on to the R580. So the R580 was introduced last year, October timeframe, I believe. Okay. And when we look at these key features, it all kind of starts with the R580. Okay. We'll talk about a little bit. I'll touch on the R780, which I talked about last year, and the R12i, which I talked about 2 years ago at this event. But it all kind of focuses around the Maxwell 7. So that is the chipset that we use in there. It's what allows us to do the heavy computations that we have for the RTK engine, which is the ProPoint engine, upper left in that slide. And it is just the enabler for everything, right? So without that, you know, I used to be in testing before I joined the sales side of things. So I did testing for about 10 years. I can't tell you how long that we were testing. That engine was called Titan when we were testing it. But we tested it for a long time. And when we would take that engine and run it on an R10, the first version of the R10, okay, which was running a Maxwell 6 chip, we would max out that CPU between basically 90 and 100% all the time. Okay. The heat that it would generate was immense. The battery drain was immense. And, you know, any of you out there, and I'm not a computer guy, but any of you out there that are, you know, more adept at computers probably than I am, you know that if you put a CPU in that type of situation where it is basically maxed out and you are just pushing it to the limit, you are going to really decrease the life cycle of that. So again, everything that we're talking about here is all enabled by that Maxwell 7 chipset that we've got. Okay. I've already kind of talked about some of this enough, but this is just what the Maxwell 7 enables us to do. Okay. ProPoint, okay, that is the engine. We'll talk about that in the next slide a little bit. Everest Plus is our multipath mitigation. So I'm sure most of you, or if not all of you, know what multipath is, but that is just when a GNSS receiver receives a reflected signal as opposed to a straight signal coming straight from the satellites that are out in the sky. So that's a negative thing, right? That inhibits what we can do with the GNSS receiver. So, but all these things, all these bullet points are enabled by the Maxwell 7 chipset. Okay. So it is, again, the foundation is the best word that I can use for our GNSS platform right now. And basically what we're doing is introducing that into the R580. Okay. So ProPoint is the RTK engine that runs on the R580. It's also the RTK engine that runs on the R12i. It's also the RTK engine that runs on the R780. Okay. So basically what we're doing, and I'm sure some of you saw the similarities, right? When you look at the R580, it looks like an R2. Okay. But again, that is where the similarities stop, is on the exterior appearance of that unit, right? All of the guts are new. And again, the ProPoint is what enables us to get into those challenging GNSS environments, whether it's tree canopy, whether it's an urban canyon. It is just an enabler, right? It allows us to work in places that when I first started working with GPS back in '97 with a Trimble 4800 unit, that I never thought that I would be able to work in. Okay. And again, that's the combination of the Maxwell 7, the ProPoint engine, and then the Everest Plus, right? So Everest Plus is just an advancement on the original Everest technology that we did. And again, all we're trying to do is improve that multipath mitigation. Okay. So I talked about this a little bit. Just because they look the same does not mean that they are the same in any way whatsoever. Okay. R2 used a Maxwell 6, the R7 uses the Maxwell 7, right, that we've talked about. You go from the old Astra engine, okay, to the Trimble ProPoint engine. Again, opens up all sorts of doors. Now, one of the things I do want to point out with the R580 is that in its current form, it's only available in a centimeter level precision, okay? And the other thing we can do is we can use the R580 as a base station, okay? So a couple of things that we could never do with the R2. Now, when we do use it as a base, again, I just want to throw the caveat out there. It does not have an onboard modem, okay? So we can only use it as an internet base currently. And if you're going to do that, you have to have an internet source at the base station, okay? So just wanted to throw that caveat out there, all right? So here's the software that we support and the data collectors, okay? You can see the TDC6 up there at the top, right? That is what we are going to talk about next. And, again, it's always important to kind of point out some of our partners out there. So Esri down there at the bottom, right? It has been tested. The R580 has been tested with that. And again, this is a receiver that is not going to fall just simply on the survey side, but is going to fall on the high accuracy, asset management side for GIS professionals out there as well. So this is just a slide kind of showing the current portfolio that we're at. I think that there are probably many of you out there that are running. If we go left to right here, we first start talking about the R12i, all right? And that is the flagship receiver that we have. The testimonials that I have heard from customers and the dealers basically speak for themselves. When you take this thing out and you put it in environments that a GNSS receiver simply should not work in. And again, not to beat a dead horse, but that Maxwell 7, that ProPoint engine, that Everest Plus, those are all things that when you combine them together, make these receivers hum, right? And so now the similarity that you have with all these receivers, the R780 is next, the 580 is next, and the DA2 is the last one in there, right? They are all running ProPoint, okay? Different levels of functionality within each of them, but again, they all run the ProPoint engine. So you've got that confidence when you go out that that ProPoint can bring you, right? So I think that's ultimately important. When that R580 was an R2, we had a little bit of a gap right there, but this just kind of completes that picture. All right. So the next thing that we're going to talk about, this is the last thing as well, is we're going to talk about a new data collector. All right. And this data collector was just announced last week. So it is brand new. On the Trimble side, we call it the TDC 6, and on the Spectre side, we call it the Mobile Mapper 6. All right. Again, same hardware, different wrapper. Okay. Key features that we've got there. One is going to be the weight. Right. I'll have a slide coming up where we're going to kind of compare this data collector with its predecessor, which was the TDC 600. But we've had a significant reduction in weight. We've had a significant increase in computational power with that processor. The operating system is a big thing. Okay, it is why we needed to come out with the replacement for the TDC 600. And again, we'll talk about that in a little bit. Plus, it's got a little bit larger screen, right? So here's just a little bit of a deeper dive into those features. The top 4 bullets we've really already talked about. Okay. Some of the other things that I want to highlight in here is just the hot swappable battery. Okay. You will see when we compare this to the TDC 600 that it doesn't have quite the battery life. Well, if we're going to reduce the weight of the unit with the amount that we did, we've got to sacrifice somewhere. And one of those is going to be in the battery life, right? But making this battery hot swappable is a good swap, right? And again, the battery life is it's gone from approximately 15 hours with the predecessor to about 9 hours with this. So again, that's still a really good day out working in the field. It supports all constellations. One of the other things that's important here is it supports Google AR Core. So that's augmented reality, and that's an SDK platform that you can build on. Okay, so it's one of the things that we build Sight Vision on. All right, and so this device is going to support Trimble Sight Vision really well. When the last thing I just want to point out there is the 2-year warranty, right? So that is pretty standard with all Trimble data collectors. Here's just a snapshot of all the different comms that we have on it. So again, new updated Bluetooth, new updated Wi-Fi, right? Where we're typically talking about 2.4 and 5 gigahertz. Okay, with the newest Wi-Fi, you can get into that 6 gigahertz range. All right. It does have a 5G modem on it. All right. And, compared to a 4G with the TDC 600, it's all USB-C. So again, that enables for super fast charging, right? Anybody that's got a newer version of an iPhone, I do not, but my wife does. She's always amazed when it runs down to 0, how fast she can get it back to almost 100%, right? It's less than an hour. USB-C enables really fast charging. But the one thing that is completely different with this than the predecessor is this NFC, this near field communication. So what near field communication is I guess the best way to describe it from my standpoint is an example, right? So when we go to the grocery store or any place and they've got the credit card reader, it used to be in the old days that you had to swipe. And then credit cards came out with a chip, right? And then you had to stick it in and let it read the chip. And now we're to the point where we don't have to do either of those two things. We just sit and we tap it on the credit card reader. Okay, that is an example of NFC. Okay, And what NFC will allow you to do out in the field is if you've got like devices, you can get them close together, you can initiate the process, and then you can transfer data between the controllers, okay? So from an environmental standpoint, right, just as I think you would expect from a Trimble data collector, right, it's got a great operating range, it's got, you know, great IP ratings, great mill ratings down there. You know, as far as this storage temp goes, right, there we're just kind of constrained. It's got a lithium ion battery, right? So based off of, you know, the physics behind lithium ion batteries, right? That's where we're constrained right there, right? To those changes based off of different times, right? But anyways, a very rugged data collector, right? And honestly, it, you know, it looks like a phone, right? So that's kind of tells you how light it is. One of the things I did not mention previously was that we were talking about the 5G, you know, the 5G modem on there. So the TDC 600, its predecessor, supported voice as well. This device does not support voice, right? So our feedback from the market was that, you know, everybody carries a cell phone with them anyways these days. So we did not need to spend our time or the effort to have this device support voice when again, everybody's going to have a cell phone with them anyways. All right. So this is probably, I think, one of the most important slides about this particular device. And the reason is because when we released the TDC 600, we released it with Android 10 and it was not upgradable, okay? This device is going to be released with Android 12. And at a minimum, it is going to be upgradable to Android 14 when Android 14 comes out, okay? So, you know, that is in my mind, that's a big improvement over the TDC 600. It allows for more usability, more updates, more security that we can provide there. So again, very important that again, it ships with 12 and it will be upgradable at a minimum up to Android 14 when that comes out. So this is just a little bit of a chart that does some comparison between the predecessor, the TDC 600, and the TDC 6, right? So the top line, you can kind of see that reduction in weight. You know, we lost almost 100 grams off of that, off of the new device. And so again, when you are carrying around a rover rod all day, you know, any weight savings is appreciated, I think, and important. You can see the operating system there. Again, we just talked about that. Those hot swappable batteries, okay? Here's the battery life that I talked about earlier, okay? Now, what I want people to realize is that when we say 9 hours at full brightness, that was, there were certain settings that we did in there to try to make it real world, right? So again, that screen brightness was all the way up. That's going to help your usability in bright sunny days. You guys get plenty of those in Utah and Nevada, just like we do here in Colorado. You know, the Wi-Fi was on, the WAN was on. We had GNSS corrections there, N-trip corrections. We had the Bluetooth on. We were connected to a GNSS receiver, and so those were some of the things that we did to try to simulate real world usage there with that to come up with that 9 hours, right? And then of course we were running Trimble Acess in the background. All right. You can see we did increase the RAM. You talk about you know, the cellular, right? The 5G compared to the 4G, and you know, again, other updates, right, as far as the Bluetooth and the Wi-Fi go. Okay. So here's just the supported software. Now, I don't want to confuse anybody on this, okay? But if you bought a Spectra version of this, the Mobile Mapper 60, you would be able to put these softwares on there, okay? You would not be limited to buying a Trimble device, putting Trimble software on it, right? So But here's the list. You've got third-party, Esri software in there as well as Android third-party apps. Okay. Now here's the hardware that is supported. So again, with that faster processor, okay, one of the things that really stuck out to me was that this device can now support the SX10 and the SX12. Okay, so it supports all of our GNSS systems. It's going to support all of our mechanical total stations, all of our robotic and auto lock total stations, as well as the SX. Okay, so the SX series is just a little bit higher requirements because of the fact that we can collect that scan data. All right, and again, that as the product manager described to me, that processor that we've got in this device, she called it a Ferrari. So that's a good thing, right? So as far as the Mobile Mapper 6 goes, again, we are not limited to putting these softwares on the Spectra device, right? If you bought a Trimble device, these could go on there. So again, I don't want to confuse anybody as far as that goes. Now, the supported equipment, if we are running Origin, okay, is going to be the SP85, the SP60, and the Focus 50, okay? So that's where this is coming from. I put this slide in there because I think it is useful and probably underutilized by our customer base. So if you go to mcs.trimble.com, and again, you may not run a TDC 600, you may not run a TDC 6, but maybe you run a TSC 7 or a TSC 5. Maybe you run a tablet, right? This website is going to contain, all operating system updates, BIOS updates, firmware updates for any of those handhelds, tablets, data collectors, plus the Empower modules, right? So really, really useful website. If you're maybe having some connectivity issues or something like that, again, this is one of the places that I would go and then I would check out. So I know I went through that kind of fast. Wanted to try to get back some time there for these guys, but I do appreciate everyone's time. I'm happy to take any questions, and if you don't have any questions right now and they come up later on, please feel free to reach out to Troy or Ryan or Jeff or Jason, Mike, any of your points of contact within the Monson ecosystem. And, if they can't answer it directly, they will certainly reach out to me. One of the other things I wanted to point out on this slide, right? I put this in there in the last second, but we do have more webinars on our website. So basically all of those slides, that slide deck that I just put together was kind of me taking slides from those introductory presentations of those products, right? Those product managers, when they talk about that, are going to go into some more detail because they'll basically take an hour for each product. So if you want some more detail about any of those products or anything else from the Trimble, that Trimble has out there, go to that website down at the bottom in yellow and dig through there, see what type of webinars that we've got out there.